Good morning, ladies and gentlemen. The Hurricane Watch team is here with a tropical weather update. We have quite a bit I want to talk about. So first, we're going to start off with Filippo, which is continuing to dissipate as it emerges away from the coast of Africa. Here's the latest update. So as you can see, there it is moving at 11 knots. There's its location just right off the coast. It will be moving over warmer water, so it is expected to intensify. However, no direct impacts are expected to anyone. Indirect impacts, maybe some rough tide, some rough rip currents there on the southern portion of Madagascar and on this side of Africa, on the east side of Africa. Other than that, really, this is going to continue to move away, and as it gets pulled down by the jet stream, it will quickly dissipate and quickly, rapidly accelerate and move away from the continent of Africa entirely. So this system is just really dissipating, really going to be, it's going to shrink a little bit. As you can see there, 65 knots, about 75 miles an hour. Once that happens, that will be its peak, and then it'll begin dissipating. But really, it's not really a whole lot to talk about. It's just, for this system, just another system that we're watching. So as you can see, it is moving away from, again, the mainland coast of Africa. You can see a lot more convection here, right here. So we may right along the immediate coastline of Africa. We are still seeing some thunderstorms and some showers occurring in that area too. So I do want to talk a little bit regarding the wind, regarding the rain in that portion. Southern Africa. So there isn't really, again, a lot going on in terms of that. There's just a teeny tiny bit right along the very southern tip of Mozambique where we are still getting some of those heavier thunderstorms and some of that rain still. This is the wrong one. No, this is the right one. Yeah. So I want to look at see if I can take a look at the radar here. If we even have a map. No, there's no radar data, which is okay. So you just look at precipitation. So these are just precipitation forecasts. These are models. So again, just right here, right along the immediate coastline right here. That's kind of what we're looking at right along the immediate coastline where we are going to be seeing any sort of rain. But again, this is going to be moving away from the coast. And really right near the core is where we're going to see the strongest winds. And right in these feeder bands here that feed into the storm is where we're going to see some of the heaviest rain, where we could see up to 1 or possibly multiple inches of rain falling in a given hour. But again, all of this is moving away from Africa, away from South Africa, and away from Mozambique. So that's the really main threats with this system. That's the main worries I have with this system, and then from there it's just going to move away. So I do want to look at the H-WRF for Filippo. So again, if we look at this, control button by accident, which takes a screenshot. Alright, so there it is. You can actually go back in time to where it made landfall. About not a hurricane, but a pretty strong 60-65 miles an hour at landfall. As you can see, as it is emerging off, here it is in the future. It is expected to intensify. I don't think it'll get that strong. That's it's pretty strong right there. But I think 75-80 miles an hour is certainly a possibility. And then, as you can see, it just gets pulled away. So this is just going to be an ocean storm from here on out, as it does start to reorganize and strengthen once again. But again, it's just going to be an ocean storm. It's going to be a fish storm. It's not going to be affecting anyone except for marine interests in that region, the South Indian Ocean. That's really it for that system. That's really all I really wanted to talk about, since again, this isn't going to be impacting anyone. As you can see, it is moving away from Africa. Here it is, right off the coast, 999 millibars. And again, it'll be moving away. It will strengthen a little bit, and then it will weaken as the jet stream, pulls it apart. 18S is trying to get itself organized. It is a storm that I am watching here at the Hurricane Watch, and we are monitoring. The models have been showing it is going to intensify. We could see a major hurricane on the Saffir-Simpson hurricane wind scale up to a category 3. Upwards of at least 115, 120 miles an hour are possible. Yesterday they were showing 935 millibars. Very, very strong, of over 120, 130 miles an hour, category 4 hurricane there. So, on the Saffir-Simpson hurricane wind scale. So this is what we're looking at now. As of right now, according to the Joint Typhoon Warning Center, we do not see impacts are possible. But you can see this portion of Australia is in the cone of uncertainty. So we could see definitely rip currents, certainly along this entire coastline of Australia. Rip currents are going to be possible. Heavy rain is certainly going to be possible. Heavy bands of rain are going to be certainly felt. And then rough seas all along the coastline right there. Now, if it does make landfall, we could be dealing with some storm surge, widespread outages across this entire area. It does seem very heavily, sparsely populated, so we're not seeing a lot of towns affected. But the towns that are affected, we'll see significant wind damage to buildings, homes, infrastructure, and the possibility of an isolated tornado is possible. And then also dealing with the storm surge, which produces a huge amount of force, lots of flooding, very catastrophic, and then dealing with obviously those hurricane force winds there at the immediate landfall there. So we could see 100 plus mile an hour winds, gusts 115 plus miles per hour. So the winds are would be very, very strong, and we would see strong hurricane force winds for depending on how fast this is moving. Now if this just keeps on moving like this shows, it would come through and out, and it would be out of there. But if it's a slow moving system, usually what causes storms to be slow moving is resistance. What would be resistance? An example, high pressure, something stopping it. We had that example in during Harbor, where we had high pressure over the mountains, and then we had a high pressure over the eastern portion of the United States near Tennessee, and that kind of caused a ridge to build in the central part of the United States, which pushed Harvey south. But as they moved north, it was able to slowly move into Texas, and then the ridge grew and got stronger, and so it pushed it back over the Gulf of Mexico, and then it was able to find resistance as those two high pressures moved away. It was able to find an area of least resistance and go right up the middle of that. So that's kind of what we look for, but as of right now, it doesn't seem like it's going to be slow moving or anything. Looks like it's going to be relatively just going to move right along. It's going to take its sweet time intensifying, but once it moves into those warm waters and we don't see any wind shear and we see everything just kind of set up correctly, it's going to explosively intensify and it's going to rapidly strengthen. And that's kind of what we're watching. That's when we don't know where's that point going to be. Now we think that point is going to be roughly right around here. Once it reaches it, that's when we think it's going to rapidly intensify, and that's when we could see this storm really take shape and intensify. So something we'll be closely monitoring when this does happen. Now, if this were to make a landfall or its closest approach to Australia, if it's a day that I'm off and I'm free, we will be doing a live stream coverage of this storm. Even if I'm not free that day, we will still have an automated live stream, which is about the best that we got right now. With that, hopefully I am off. So, I do want to talk a little bit about the modeling about this system and where it's going to go and what we're dealing, what we could be seeing with the system. So Australia, again, there it is off to the east right here, or off to the west, excuse me. Australia is off to the east. So there you go, you can kind of see, still looks relatively sheer, doesn't look very well set up vertically, still looks kind of lopsided. But as you can see, boom, right there, we kind of see that hook moving around the center there. And that's sort of the idea that we're looking for. That's when we think it's going to explosively intensify. When we start to see it set up correctly, and it's not all lopsided like it is now, that's when we think it's going to rapidly intensify and just sort of take off. And this one model does, in fact, bring it to a landfall. Fortunately, it does look like it weakens before it makes landfall, as it does look like its strongest is at 956 millibars. Alright, herds. So I do want to look again. This is the GFS model. This is, again, 18S. Pretty more significantly strong system there. Again, 954 millibars. It does, in fact, look like there is going to be an eye with this system. So that does show a pretty intense system, but it does begin to fall apart. Probably the intrusion of dry air would be my guess. which causes it to weaken, and then it quickly makes landfall. So again, this is not going to be a slow, super duper slow moving storm, thankfully. Now, when we're coming to the here it is. This isn't as predictable when it comes to wind speed, but more predictable when it comes to location of landfall and its track. So we do use this for tracking. Fortunately, this one particular model, which has been relatively very predictable when coming to track, does not show it getting really anywhere near Australia at all, thankfully. So we are going to watch just to see with all that we got with this system. Now, again, we are watching another system up here. This system up here is another system that we were watching. It does in fact show. It certainly takes a long time before it actually gets going, but if this is the case, this could be a much stronger system that we're dealing with. Again, 975 millibars at landfall. And again, these are fast-moving systems. These are not slow. These are going to make landfall and just keep moving. They're not going to stall, which is certainly something that we look for in terms of, which gives us an idea of how strong is this going to be. You know, on a scale, how bad is this going to be? And if it stalls, that's going to significantly change things, because this could be a significantly more catastrophic event than if it just keeps moving through. See, with Hurricane Michael, yes, it was a catastrophic Category 5, 160 miles an hour, and stuff like that. But what was good about it is it kept moving. It didn't stall. If it would have stalled like Hurricane Dorian did over the Bahamas, it could have been a catastrophe. And it could have been even worse for Mexico City Beach. Mexico City Beach was already heavily damaged by the storm surge and by those 160 mile an hour Category 5 winds. So, when these storms just move through, it's much better than if they stall. Absolutely catastrophic. That's something I want to point out to. Another thing that we have been watching is we do have these other systems. Invest 93P just looks like it's going to move away from Australia, but could produce a lot of heavy rain in this region of the Pacific. Invest 94S is one that I'm a little bit more concerned about. Here, as you can see, it does look like it has been trying to develop. We do see a lot of convection, a lot of heavy rain already beginning to occur. And this is a system that we are watching now. If we go to the forecast models and we go to Australia, you'll be able to see exactly where it's at. Boom. Right there. No, right there. Right there is the other system that's going to continue to move east. We'll play this through the modeling. Moves right on east. However, this system here does take its sweet time as it moves through and into the Gulf. It does strengthen and develop here. It makes landfall again. And then we could be dealing with another system. Now, anything really out 160, 200 plus hours out, we don't even look at it. But the only reason we ever do go that far out is just, okay, there's a potential where we could see a tropical system. There's a possibility that conditions will be favorable for a tropical cyclone to beginning to develop in about a week and a half to 2 weeks. If that is the case, we will be watching for conditions that will be suitable and favorable for tropical cyclone development. That's the only reason we look out that far. It's because there's already showing the possibility, so that could be something we'll be definitely watching. So that is the other system that we're watching. It is expected to make landfall, move into the Gulf, and that's where it will intensify. And it does certainly look like it will produce a lot of heavy rain. Now, if that other system does make landfall, ask me something else we'll be watching around the time that makes landfall. This one here could also be making landfall. Right there. So we may be doing a live stream covering two systems at the same time if they're both making landfall at the exact same time. So that's going to be something we're closely monitoring. And but yeah, that's kind of what we're looking at with those two systems. And then later on, dealing with possibly, again, the potential, not saying it's going to happen, but the models are already showing a possible tropical system developing. So they're already saying the conditions are going to be suitable and favorable for tropical cyclone development, possibly in a week and a half to 2 weeks from now. So that's really going to be it, guys. That's what we're watching. Those are the storms. Here's the Joint Typhoon Warning Center. There's Filippo off the southeast coast of Africa. There's 18S right there. And then we got 94S and 91P. 94S being in the South Indian Ocean, covering this area, and 93P being on the right side of that line, meaning it is considered to be in the Pacific Ocean. So really, depending on what side of Australia you're on, you could be getting a storm that is South Indian or Pacific. So, in this case, this is going to be a South Indian system for 94S and TC 18S. 93P will be Pacific. So, for 18S, again, this is the latest satellite imagery. Try that again. I don't understand. What am I doing wrong? What the heck? That's not what I wanted. This is... Nope, not, okay. Still not what I wanted. This is strange. Can I get... Yeah, because these systems are developing, but they're not... There we go. So again, it is... You can kind of see it's being sheared in from the east, blowing that convection away from the center, the low-level center of circulation. That's what's really preventing it from intensifying into anything. That's the main cause of why it's not rapidly intensifying right now, is the wind shear is blowing all that convection away from the center of circulation right there. You can even see it's so disorganized. So you can clearly see the wind shear this way, and then we also have this other system. Well, it's actually way over here. Let's see, true color. As you can't really see, we are trying to get a lot more convection, but so we got wind shear coming in this direction. See wind shear coming in this direction, and then we got wind shear going this way. So that's what we're looking at with this system. Very disorganized. It is developing, but that is what's causing it to not rapidly intensify right now. Is currently disorganized. And then this system is another system that we're going to be monitoring very closely. But really, that's it for today, guys. Again, thank you all who are watching this video. Links are in the description if you want to join our Discord server. Comment any questions that you have, and I will respond to them as quickly as I possibly can today. Again, I do go to work. Actually, I got like 30 minutes. I got to clock in. That's going to be it. Thank you for watching. This has been the Hurricane Watch Team, your source for cyclone information. As always, take care out there, stay safe, and peace out.